Hello, everybody. So today we'll start with the hypothesis testing. So I was just giving one presentation on the hypothesis testing few minutes back, and I'll quickly share my screen and I'll explain you what the hypothesis testing is all about. The idea of the hypothesis testing is to understand whether the process, it's a process to evaluate the strength of the evidence from the samples. And it's kind of provides a kind of a framework for making the determinations related to the population. That's it provides a kind of a method for understanding how reliable one can be, with one particular sample. For example, you are drawing a sample from the two population A and population B. Now you want to understand whether how close this population are. What happens in the biomedical research or any kind of statistical research, we collect the data to test those relationships and try to draw the conclusion about those relationships from the data collected. So in many cases, what happens is that analysis, the investigations which you do the data, the test relationship by comparing the average level of the factor between the two groups, the group 1 and the group 2. Now we have to find out whether the true data in the true testing of the hypothesis testing is a process of drawing the conclusion on basis of a statistical testing, which is collected on the data. So there is a specific approach to test means on average level of collected data. Like we have a kind of different tests we will do to understand. The first step in hypothesis testing is that the transformation of the null hypothesis HO and the alternative hypothesis HA or H1. So null hypothesis and alternative hypothesis are the concise statement, which is used in a mathematical form, like possible variation of the truth about the relationship within the interest of the two groups. So now what we do is that what is the hypothesis testing is a kind of a systematic procedure, you can say. It's a systematic procedure for deciding whether the result of a research study supports a particular theory which is applied to a population or not. Okay, like it defines whether the testing using the sample data to evaluate the hypothesis of the population. There are 5 steps of the hypothesis testing. First of all, you select whether you state your null and the alternative hypothesis, that is HO or H1 or HA, and then you collect the data, perform the statistical test, and then decide whether to reject or fail to reject your null hypothesis, and then present your formula. So these are the steps are involved. So over here we have to start off. So generally, the goal of the hypothesis test is to rule out the chances, the sampling error, as a kind of plausible explanation. So we do a kind of a research. We collect the sample from the different two groups or 3 groups, and then we try to find out whether there is a kind of a chance to test or not. You can reject the test or not. So hypothesis testing is a kind of technique to help to determine whether the specific treatment has an effect on the individual in the population or not. So how we kind of select sample selected from population, treatment is administered, then after the treatment, individual sample are measured. Now there are 2 things: whether there is a kind of treatment has an effect, or treatment doesn't have an effect. How we know that treatment has an effect or doesn't have an effect? By the kind of possibility of the p-value. So we define the p-value. P-value is nothing. P-value is a kind of, okay, before we come into the p-value, let us understand the null hypothesis and the alpha level. So the following 4 outline process of the hypothesis testing is done. The first one is the null hypothesis, the H0. H0, what it does is it always states whether the treatment has no effect, no change, no difference. So whenever you have a null hypothesis HO, you have to understand that there is no change, no effect on the data. According to the null hypothesis, the population mean after the treatment is the same as it was before from the treatment. So it's the same thing. Okay. The alpha level establish a criteria, the cutoff. We have to define our p-value is more than 0.05. So that's an alpha level. So for making a decision about the null hypothesis, you have to set our p-value. That also defines your type on error. Okay, so this is how it defines. So this is the Gaussian distribution of the data, and this is how your p-value defines. If it's negative, it's coming to this left side, and if it's positive, it comes to the right side. Critical region is the kind of your critical region which consists the outcome that are very unlikely to occur in the null hypothesis. Okay, so that's a critical. There are multiple tests we do. I'll come into all the tests we do, and then I'll explain you. There are a few errors in hypothesis just because the sample means we have a kind of, we should recall the sample mean, it's a kind of different origin. So I'll come into the errors, error 1 and error 2, type 2 error, type 1 error. So what is type 1 error? Type 1 error occurs when the sample data appears to show a treatment effect, when there is a kind of effect with that particular treatment. In case type 1 error caused by the unusual, unrepresentative samples, just by the researchers like select the extreme samples, samples falls in the critical region, even the treatment has no effect. So there's a kind of a type 1 error. Now, hypothesis test is structured so that type 1 error are very unlikely. Specifically, the probability of type 1 error that's equal to the alpha level, which is 0.05. Now, the another thing about the type 1 error test is that you have a kind of rejected and not rejected. Null hypothesis rejected and not rejected. If it's rejected, true, type 1 error, false positive, probability is equal to the alpha value. If it's false, the correct decision, true positive, probability is 1 minus beta value. So that those things you have to define how your type 1 and type 2 errors are occurring. So type 1 error means rejecting the null hypothesis when it is true. Type 2 error, failing to reject the null hypothesis when it is false. So there's something called type 3 error, which is correctly rejecting the null hypothesis for the wrong reasons. Okay. So what is the type 1 error? Type 1 error is something when we reject the null hypothesis when it's true. Type 2 error, failing to reject the null hypothesis when it's false. These are the two things. And there's a kind of a difference between the type 1 and type 2 error, like the false negative conclusion. Type 2 error is nothing but it's a kind of false negative conclusion. Type 2 error is nothing but a false positive conclusion. Okay, this is when I was talking about the actual situation, reject or not to reject. There are different tests we can do, we will not explain all those things. Okay, let me come into the practicality now. Okay, so over here, I believe my screen is visible. We'll understand few things. These are all your statistical tests which you have to follow for your data. The first thing is the normality test. What is normality test? Normality test is nothing but, let me explain you why you are doing all these things. See, when it comes to the assumptions such as the distribution of the data, how the sample size would be, what is the result of the test likely to be, it might become very good, very bad, it can be immediately unusable, usable, it can be anything. So data samples need to be represented in the domain and the large enough. There has to be kind of distribution, has to be analysis. You cannot use the entire data. You have to understand the data size sometimes might be very less, very small. You don't know. You have to kind of analyze the distribution of the data. So while we do the distribution of the data or analyze the distribution of the data can be corrected to meet the assumptions. Such corrections are required nearly the normal distributions. So when you say the normal distributions mean removing the by the outlier or doing some kind of correction of the degree of the freedom. The statistical test we do the statistical test to understand when the samples have a difference, kind of offering the variance of the two examples. Okay. So finally, there may be multiple tests to a given concern. Like we have a normality test, stationary test. We have a kind of multiple test. So we don't know which of the tests to use. So for that reason, we do multiple tests to make sure that our data in a correct way. The first thing we'll do is a normality test. What is a normality test? Normality test is nothing. It checks whether the data has a Gaussian distribution or not. So what is the Gaussian distribution? Gaussian distribution, nothing is, it means when the data is a kind of a bell-shaped data. In the Gaussian distribution, what happens? So in a Gaussian distribution, your mean, median, mode, there's the calculation of the mean, median, and mode in the Gaussian distribution, which I'll explain you. The mean, median, and the mode are exactly the same in the Gaussian distribution, the normal distribution. In a normal distribution, your mean, median, and mode is all same. So normal distribution have a kind of a key characteristic that is easy to spot in the graph. The distribution is symmetric about the mean. Half the values fall below the mean and half above the mean. So distribution can be described by the two values, mean and the standard deviation. So normal distribution have some kind of formula. It's a kind of completely bell-shaped curve. Okay. The normal distribution, the properties of the normal distribution, the mean, median, and the mode are exactly the same. The distribution is symmetric about the mean. And the normal distribution, the mean is location. The mean is the location parameter, while the standard deviation is the scale parameter. Okay. All right. So this is a kind of a normality test. So for normality, we are doing the Shapiro-Wilk test. So what Shapiro-Wilk test does is that Shapiro-Wilk test will try to find out whether the data sample has a Gaussian distribution or not. The observation in each sample are independent and identically distributed. That's an assumption we have. So let me quickly ask me on the Jupyter notebook and write down the code. I have already written this code, so I'll quickly, I'll quickly run it. See, if you have the p-value, so p-value is defined as 0.193, which is probably it's a Gaussian distribution. What is a p-value? I've already explained you. P-value is a threshold point where it defines whether the given kind of given data has a kind of the Gaussian distribution or not. The p-value defines the threshold of the data. The p-value is a statistical measure which helps to validate the hypothesis against the observed data. Okay, so you can say whether the given hypothesis is wrong or not. And what is the purpose of your p-value? P-value is a probability value. It tells you how likely that your data could have occurred under the null hypothesis. Value ranges from the 0 to 1. So the p-value of the probability that the null hypothesis is true, it's 1 minus the p-value. A low p-value shows that the results are replicable. A low p-value shows that the effect is large on that result of the measure theoretical clinical. If the p-value is much more lower, the greater statistical significance of the observed difference. So low p-value is the greater significance of the data is highly reflexible. And high p-value means that when you have a high p-value means that that indicates that your evidence is not strong enough to suggest that effect exists in the population. So high p-value doesn't mean that the effect is not there in the data. It is possible that the effect is too small, the sample size is too small, or there is too much variability of the hypothesis test to detect it. All right. So let's run the another test. That's a kind of a D'Agostino's K2 normality test. I'll simply run this code because I've already written those codes. See over here also is 0.183. You can alternatively use the either Shapiro-Wilk test or D'Agostino's K2 normality test. You can simultaneously use it. You can see the result by running the test. Next, we come into the Pearson correlation test. Let me copy the code. Now, what does the Pearson correlation? It's a correlation test. Why we are doing the correlation test? We are doing correlation test to make sure that the statistical test that you can use, check the two samples are related or not. The Pearson correlation test, coefficient test, what it does is that it checks whether the two samples have a linear relationship or not. But there are a few assumptions. One of the major assumptions is that the observations in each sample are independent and identically distributed. The observations in each sample are normally distributed. The observations in each samples have the same variance. Okay, so that's one of the major assumptions we have. The HO, like the two samples are independent, and H1 there is a dependency between the two samples. So over here, probably they are dependent. Okay, so let me do another test. Spearman rank correlation. It also does the same thing. Pearson rank correlation. So let me quickly run this code. All right, let me share the code now. All right. Okay. Go through the code, guys. If you have any problem, do ask me. And the next one is the Kendalls rank correlation. Kendalls rank correlation, what it does is that it also tests whether the two samples have a monotonic relationship or not. So let me quickly run the code for you. Kendalls rank correlation, it evaluates the degree of the similarity between the two sets of rank given to a sample set of data. And the p-value over here, it states the probability that the measures the evidence against the null hypothesis. Over here, the p has been set is more than 0.05, which is the alpha value. And the Kendalls coefficient, this is used to measure the original association between the two measured quantity, non-parametric hypothesis test and the coefficient test. The rank correlation, what it does is that the significance of the ordering of the data when the rank by each quantities. So they try to find out the rank correlation of the ordering the data when the rank by each of the quantities. The next one is we'll do the chi-square test, which is a very famous one. Again, in the chi-square test, why we're doing the chi-square test? We're doing a chi-square test because to make sure that the two category variable related to independent or not. So over here is independent. We'll come to the stationary test now. In the stationary test, one of the famous one is the augmented Dickey-Fuller test. This helps you find out whether the given series of the stationary or not. This is mostly used for the time series forecasting. Okay. They're probably not stationary. Now, why we're doing this stationary? The reason we are doing this ADF test to make sure that there is a kind of the more the negative, the stronger the rejection of the hypothesis. Okay, so ADF test helps us to find out whether the Dickey-Fuller larger the more complicated set of the time series or not, series is stationary or not. There is a feature called unit root. Unit root is nothing but unit root is a feature of some stochastic process. Similarly, like to the ADF, we can also use the Phillips Schmidt Shin test. This also does the stationary test, and whether probably the data is not stationary. Now the another thing is that we'll do the student test. So why we'll do the student test? I'll explain you. Let me quickly I run the test over here on the Python notebook. We will do the student test. Make sure to this is a kind of a parametric statistical hypothesis test. Now, when I'm doing the parametric statistical hypothesis test, it's nothing but it's a kind of a statistical test that we can do to compare the data samples. In the student t-test, the test, it tests whether the means of two independent samples are significantly different or not. There are a few assumptions. Observation in each sample are independent, identically distributed, and the observation in each sample are normally distributed. Observation in each sample have the same variance. That's one of the assumptions you have. Go through the code. I'll explain the student t-test more in a detailed way. So student t-test is also called the t-test, used to compare the means between the two groups, and there is no need to of multiple comparison as in the unique p-value is observed. Whereas the ANOVA, okay, so the t-test is generally used to compare the means between the two groups. The distribution we will also come into the paired t-test as well. Let me write down the code for the paired t-test. So what is the difference between the two t-test and the paired t-test? T-test should be used for the different data structures. Okay, and the paired test is used when the data of the two samples are statistically independent. And the paired t-test is used when the data is in the form of the match pair. So that's one of the major difference between the t-test and this paired t-test. T-test will be using the t-test for like probably by use when the comparison the mean values between the two samples. There's few confusion with this. Like we have to define the student test is like it's known as a student t-distribution under the full null hypothesis. It's very commonly used applied when the test statistic would follow a normal distribution. If the value of the scaling term is the term statistic but not known. Okay. Yeah. The next will come into the ANOVA. This is the code of ANOVA. Why we are using the ANOVA? ANOVA is the like analysis of variance. It also does this will test whether the means of the two or more independent samples are significantly different or not. So in ANOVA, we have a kind of a dependent variable, we have an independent variable, we have a null hypothesis and an alternative hypothesis. There are a few factors which affect the ANOVA. That in like the fixed factor model, we have a random factor model. Now in a fixed factor model, like we have only a discrete set of the labels of the factor. For example, a fixed factor test would testing the three different doses of the drug, which are like kind of not looking for any dosages. So there are three factors, fixed factor, random model factor we have. So we are over here. We are doing the one-way ANOVA. So the ANOVA is a kind of one-way. This is only used when one independent variable, one independent factor, the two or more levels. For instance, the dependent variable may be with the month of year, and there are the more flowers in the garden. Okay, so that's a kind of ANOVA. So why we need the ANOVA? The ANOVA is used to, it helps to allow a comparison or a more than two groups. It allows a comparison between two or the more groups at the same time to determine whether the relationship exists between them or not. Okay, there are the two groups, and we will do the comparison of the two groups at the same time to find out whether there is a relationship between them or not. So that's the reason of using the ANOVA. Now we'll also do the use the Mann-Whitney test. Let me run it. Now, what does the Mann-Whitney does? Is a Mann-Whitney is a kind of a this is a non-parametric statistical hypothesis testing. This will test whether you have the distribution of the two independent samples are equal or not. Over here, if you see probably the distribution of the same distribution, they are the same distribution or not. It will check. These are the non-parametric statistical hypotheses. If you look into my document, see, non-parametric statistical hypothesis, Whitney, Wilcoxon sign rank test, Kruskal Wallis test, and Friedman test. Friedman has been the very famous test. It was done by Friedman himself, William Friedman. So in a Whitney test, what happens? In Whitney test, it's a non-parametric test. So when I'm saying it's a non-parametric test, it is not based on any kind of parameterized families or probability distribution. Non-parametric statistics is completely based on either being distribution free or having a specific distribution, but with the distributions parameter unspecified. Non-parametric statistics include both the descriptive statistics and statistical inference. Non-parametric tests are often used when the assumption of the parametric tests are violated. We may use the non-parametric methods are widely used for studying the population that take on a ranked order, such as the movie review receiving 1 or 4 stars, something like that. The use of the non-parametric method may be necessary when the data have a kind of ranking, but no clear numerical interpretation, such as the assessing the preferences. We need to find out the level of measurement. Okay, non-parametric method result in ordinal data. Okay. Non-parametric methods make fewer assumptions. Their applicable is much wider and the corresponding parametric method. So I can say, non-parametric, the very robust of the non-parametric test comes at the cost. It's a kind of a, different methods are there. Histogram, KDE, kernel density estimations, non-parametric regression is there. Data like envelope analysis is there. Multivariate analysis is there. KNN are there. Support vector machines are there. So these are the things we define. So non-parametric distributions are the mathematical procedures where the statistical hypothesis testing is done. And they make no assumptions about the probability distributions. Like we have the Anderson Darling test, we have a statistical bootstrap method, coherence Q, coherence kappa. There are a lot of things are there. Kaplan-Meier, Kendalls Stock, Kendalls W, like the Kruskal Wallis or one-way variance of ANOVA. So these are the few tests are there. So I told you about the Whitney test. Now let's come into the kind of Wilcoxon sign rank test. This test also does the same thing. They test whether the distribution of the two paired samples are equal or not. But however, there are some observations. Observations are like same. Observations across each sample are paired. Observations in each sample are ranked. And observations in each sample are independent and identically distributed. Okay, so let me quickly run the test. These are all similar functions are all similar. So I'm just quickly running the code. Okay, so you can see the p-value, probably the same distribution. They are slightly different. The codes are, the p-value is slightly different. Okay, because the distribution is almost same. This is a Friedman test. I'll explain the Friedman test. Let me run the code quickly. I've already written this code numerous times. It's also available in my GitHub page. So you can just go and download the code from there. Go through the code. Let me know if you are able to find out any challenges. It's very simple. All these are non-parametric statistical tests. And the Friedman test is, I said, the name of the Milton Friedman. And then, yeah, it's a very simple method. You have a given data, you find the value, then you find the test the statistic by given formula, and then you can, whether the K or N is, you define your N value or K value, and based on that, you define. It helps the kind of, we have something called repeated measures ANOVA. That's the alternative to repeated measures ANOVA. When to use the Friedman test, when you are trying to measure the mean score of subject in a 3 or more time points, see there are three time points are there, data 1, data 2, data 3. So that's the reason we are using the Friedman. Okay, so measuring the mean scores of the subject under different conditions. So there are different conditions are there. They don't enjoy the subjects at very 3 movies rate. So how the movies are getting rated and all. So there are three different stages are there. So based on that, we are using the Friedman test. The first thing is that you state the hypothesis. Null hypothesis is HO or H1. Alternative hypothesis is H1, HA. Then you perform the Friedman test. Okay. Then you interpret the results and then you report the results. Okay. That's it. Nothing much, right? So there are 15, 16 tests which we have done. I have described why the needed of the hypothesis testing and all. Any questions, do let me know. I'll stop sharing here and I'll update the recording on the portal. Thank you.